All right. Good, very morning to ladies and gentlemen. We wake up early today. Our class is very early, right? That's we're waiting from others. We wake up early today. Our class is very okay. Can we start the class now? Right. Okay, good morning, Nurul. Okay, Putri, Azrin, how are you? Okay, Divizia, okay, how are you? Okay, Putri, and then Divya, all right, here again. We meet you again, all right. And then Nurul, how are you, Nurul? Okay. Please put your full name, right? Because I don't know. Okay, what is your name, please? Okay, because you can change your name. All right, Amelia. All right. Okay, please change your name, and I'm really if you can put photos and so on. Yeah. Okay. Okay. Are you also here? Are you? Are you Noor is here? Iskandar, okay, Daniel, Iskandar, Nurin, okay, all here. All right. So you can go to the top chat, register at YouTube, and we can meet together and ask a question if you cannot understand. All right. I'm stop sharing. Okay. You can go to the Telegram for the QR code. We are going to confirm the QR code, okay, by using a simple exercise. Don't worry, okay. We just refer what you learned before in chapter 8 and chapter 9, okay, numerical 1. Okay, we also post you the zip file, okay, at the e-learning. All right. Okay, now I'm stop sharing. I want to go to the e-learning. I'm stop sharing. Okay. Okay, because we are applying the what we call student-centered learning, so meanings that okay, I hope you can always visit e-learning. You know why? Because e-learning is a place where we can do a synchronized learning. Okay, go to the e-learning. All right, you can see my e-learning here. All right, you can see here I already post a few posts. For example, the introduction to the ordinary differential equation. What we learn in numerical 1 is a first order ordinary differential equation, or ODE. All right, first order ODE. All right, or for example, del u over del x equal to fx, for example. So this is a first order derivative. And then I'm also post you how we solve first order ODE using Euler method. All right. Euler method that I already expressed is a first order of the Taylor series. All right. And then I'm also need a feedback from you, okay, from my zip file, numerical 1, okay, on top here, okay, you can see here, I post already chapter 1 to chapter 9 of numerical 1 content or e-books, all right? Please refer, all right? And then I need your feedback about the chapter 8, how you understand on the chapter 8. And then towards the end, I continue with the next method we call as a Taylor method. Taylor methods is a higher degree, okay, for the derivative equation. So in this case, I solve Taylor series, okay, using the same question of ordinary differential equation, right? Okay, please visit at the e-books that I sent to you. This is very important. All right. Solving a first order ODE using third order, okay, of Taylor series. Okay, this is very important. We are going to bring up these ideas to the numerical tool. All right, so I'm also, okay, need your feedback about your understanding about chapter 8 that you learn in numerical 1. All right, that you learn in numerical 1. So this is the way how I guide you as a coach, and you are learning by your own, all right, by the video, by the e-content, by some exercises after this, all right, just to make sure that you understand, okay, on the previous, okay, lecture numerical 1. Okay, so let's go to the numerical 2, but we are going to use Euler method, Taylor methods, and Ranch kata, all the four, all right, all the four, okay, for solving the first order of the ordinary differential equation. All right, so I hope you can, okay, together with me. All right, I'm stop sharing. Okay, this is enough for us today. All right, if you have a time, go to the e-learning, and then you can click and then the cloud at the YouTube. So it's very easy for you to visit the YouTube, because YouTube available for what we call low bandwidth condition. All right. Okay. Now let's we go. All right. Stop sharing. Stop sharing. I want to go to my YouTube. All right. Okay, before that, okay, I want to go for this note. Okay, we go to this note. All right. Okay. Okay, we are going to do some revision. Okay, I give already this note to the e-learning after this. Okay, we are going to have a video on these notes. Okay, I just want to express here. Okay, the types of ODE. Okay, what we learned before. All right. So ODE is a higher order. Okay, order first order, second order, third order, means that the derivative is considered as order. When I said order, means that the derivative, okay, the level of the derivative is order of the ODE. ODE is a ordinary differential equation where we are using independent variable, one independent variable for many function, or one only. For example, here y is depend on independent variable x. Okay, x is an independent variable, y is a dependent variable. I just want to remind again and again to make sure that when I ask you about order, about the degree, you know the difference. All right. So what you learn in numerical 1, okay, you are really focused too much on, okay, on y prime x equal to fxy. For example, y prime x equal to xy plus y, or dy over dx equal to x squared plus y squared. All right, so this is a very, very basic, okay, about the first order ordinary differential equation. For example, y is a temperature in my room, and x is a space in my room. All right, so the temperature of this room is depend on the, okay, the space plus the temperature, for example. All right, so for example, other example is y is a tumor growth, x is a nutrition to support the tumor growth. So the tumor growth is depend on the x, which is a nutrition to support the growth of tumor, and y is a size of tumor. All right. So the second order ODE, okay, this is a common for you. I know it is common for you. Just I want to describe and then how we can solve second order ODE using the numerical method, not using calculus. Calculus, you need to differentiate for every both, integrate for every both part. All right. So you can get the solution. Other solution, you are using finite different method. We discretize y prime prime and y prime using, okay, numerical 1 chapter 6, okay, numerical differentiation. There are so many ways, don't worry. And then we also can use GeoGebra to get the solution. All right, second order derivative, for example, del squared u, del squared y over the x squared equal to x squared minus 2 dy. All right, so you can see here minus y. You can see here there is a integrated between second order okay, ODE, and derivative, second order derivative, sorry, and first order derivative. So what we call this is a second order ODE, or we can write as a x del squared y over del x squared plus 1 minus x dy over dx equal to 0. This is a one times. We are going to learn about RE, Basel function, and then we can also learn about Bernoulli equation of the ordinary diffusion equation after this. Okay, I just want to represent here the way how we can write second order derivative is based on the grid types or function type. All right, third order derivative, wow, is a okay, third order, okay, differential equation, y differential, okay, third order differential, y prime 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 minus y prime x equal to fx y prime y prime prime. I know you are familiar third order, fourth order of the differentiation. All right, so or you can write as a del squared del cube y over del x power 3, okay, minus del squared y over del x cube, okay, that's x squared minus 2. So this is what we call, okay, there is a pedal, okay, there is a curve, all right, tree curve, and then for maybe they'll go through x-axis at 3 point, all right. So this is a higher order of the ODE. We're going to learn, okay, how to solve higher order ODE using a method we call as predictor corrector Adam Bashford method, and then we also can apply, okay, Euler, Taylor, and Ranskata for solving higher order ODE. All right, so come back again. Okay, this is a type of the ordinary diffusion equation. Okay, higher order. All right, first order, second order, third order. All right. So other system of the ODE is what we call as a combination or double or what we call twins, okay, of the first order derivative. Means that, okay, you can see here, okay, the temperature behavior of this room is depend on space, and okay, Z is other parameter. For example, okay, the evaporation in this room is also depends on X is a space and the temperature behavior. So meanings that you are couple, okay, finding a parameter, okay, about this room, okay, temperature behavior and the evaporation in this room, okay, depends on the space, all right, and the temperature itself, all right. So that is an initial condition. This is a where we call as an initial condition, okay. So that will create initial value problem. Okay, the initial condition is when the space is 0, okay, the temperature is alpha. So this is a start the process solving the first order the first order ODE, okay, based on this system, okay, couple system, okay, couple system of the first order. And then this one, when the temperature is 0, so the evaporation is equal to beta. So this is a two set of the first order ODE. What we call this one as a system of first order, all right, ODE. Okay, so the specific name, okay, of this type of ADE we call as an initial value problem because there is an initial condition. All right. Sometimes you can go to the chapter 8. Sometimes we have a boundary condition. For example, the boundary condition of this room is between this wall and other wall. All right. So there is a boundary from my ceiling and the stair. All right, so this is a boundary condition. All right, so we are going to emphasize on the boundary condition later, but we start the solving ODE using initial value problem. What is initial value problem? The start point, okay, of the temperature behavior in this room, Y, and the evaporation in this room, Z. All right, okay, the condition of the initial. All right, so you can see B is a all right, you can see here the growth, for example, yeah, the growth of population is depend on time. The growth of population in Malaysia is depend on time, all right. So meaning that this one is should be y minus x. Okay, what is y? Y is maybe the economy. Okay, the economy of Malaysia growth depend on time, is depend on the population and economy itself. All right, so I can translate all the ODE using many application. All right, the real time application. All right, so okay, again, we have the initial condition. Initial condition, you can see if you focus on the growth of the population X, so the growth of population is equal to 0 when time is equal to 0. All right, so this is depends on time. All right, when time is 0, okay, the population of Malaysia, for example, is only 1. All right, the starting point. All right, the economic growth of Malaysia is depend on the population. All right, so the economy, it will be 2, okay, level 2 when when time is equal to 0, y equal to 2 when x equal to 0. We always playing around, okay, at t naught means that equal to 0, okay, and then t naught is equal to 0, x naught equal to 1, and y naught equal to 2. This is the way how we present the grid form to initial value problem. The second here is maybe, okay, I just want to put some example here. For example, okay, the muscle stress around your eyes is depends on time. All right, muscle stress, because we are look at the computer. All right, you are involved in the e-learning process. All right, e-learning and teaching, okay, mode. So you are looking at the computer. All right, so what happened? Okay, the muscle stress depend on T is equal to negative L1M. So meaning that negative, the muscle stress become decrease. Okay, decrease and decrease. All right, when the time equal to 0, muscle stress equal to 1. Okay, starting point. Okay, when you start looking at me, okay, the muscle stress around your eyes is equal to 1. All right, so the second is the muscle stress also depends on the what we call eyes movement. So D is an eyes movement. Eyes movement of the eye, okay, of your eyes is depend on time. Okay, the eyes movement is negative L2D plus L1M, where the eyes movement equal to 0 when time is equal to 0. Meaning that when you wake up early in the morning, all right, so your eyes still not move, all right, so the time is also considered as 0. So that is you put the initial value for the muscle stress. I hope you can understand, because we are going to give you many application about ODE. All right, so now I don't want to go further this one, so I want to stop sharing, okay, about this. Okay, I'm stop sharing. I want to go to how we can solve all this type of ODE, especially first order derivative. All right, so I'm stop sharing. Okay, and go to the another explanation. All right, so come on, if I can go to here. All right. Okay, you can get this video at the e-learning. Okay, you can get this video at the e-learning. Right. Okay, I'll go to the e-learning, and then let's put more bigger. If I can see here more bigger. All right, so this is a way how we solve a problem of the ODE that I presented just now. Okay, especially on the first order derivative. Okay, we are using Taylor series. What is a Taylor series? So again, go to the chapter 8. All right, we learned about Euler method, Taylor series, and range kata. Okay, I'm already explained to you. Taylor series is a higher order, okay, of the derivative, okay, equation. For example, yi plus hy prime plus h squared divided by 3 factorial yi prime 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 plus h power 4 divided by 4 factorial yi order 4, okay, derivative order 4 up to order n. So you can see here, h is what? H is a size of interval, because the domain of solution of ODE we can put in the between x equal to 0 up to x equal to 2. For example, x equal to A and x equal to B. So H is a size of interval when we know, okay, the number of grid involved in the solution domain. All right, so there is a H. So yi plus 1 is a solution of the ODE. So I is moving from 0, 1, 2, 3, 4, 5 up to n. I equal to okay, -1 means that y naught is the initial condition. Okay, y x naught is equal to initial condition. All right, so now there are so many ways to solve this problem. Okay, you can solve using Taylor series order k plus 1. All right, you can also solve Taylor series order 3. So we are focused on Taylor series order 3 because why? Okay, for the numerical 2, okay, we try, okay, to go for the higher order. All right, and then we try to solve ODE in 15 minutes. Okay, try to solve this problem 15 minutes. Okay, so quite familiar with this equation. Okay, we are quite familiar with this equation. So now okay, we can compare, okay, Taylor methods with the Euler method. Okay, what is a Euler? Euler is a Taylor methods order 1. It's only here. It's only HYI. It's only there. Okay, it's a two expression of the Taylor series. All right. Okay, now, so the other method that you can compare with the Taylor series is a Range-Kata order 2, or much more better is a Range-Kata order 4. Okay, go to the chapter 8. Okay, I'm already, okay, give you material just to remind you. All right, so now, okay, we stop sharing here. Okay, we go to another, okay, stop sharing. All right, so we try to more deep, okay, okay, we try to get more skill about the Taylor series order, okay, order 3 to solve the ODE. All right, so you can see here, okay, all right. All right, so since we know Taylor series, okay, so again, okay, I'm using the same video. All right, so that's, I stop here. I want to share a new screen. All right, let's we go to the new screen. All right. Okay, here. Third order Taylor series. Third order Taylor series. Okay, from here, okay, we want to solve this problem. Okay, what is the problem? The problem is solving the initial value problem, first order derivative. What is the problem? Y prime equal to x plus xy. What is y prime? Del y over del x. Okay, this is the only single independence variable x. Okay, the dependent variable is y, independent variable is x. Okay, so I know you're quite familiar because you learned in calculus already. And then there is a condition. The initial condition is when x equal to 0, y is equal to 1. All right, and then the size of interval between 0 and 2. You go to my yellow, okay, yellow cursor there, and h is a size of interval of your solution is 0.5, and we want to use Taylor series order 3. All right, so we want to compare with the exact solution. Why? Because we want to investigate whether Taylor series order 3 is converged very fast compared to the Euler or the Range-Kata order 2. All right, so you can compare because there is exact solution y equal to 2 exponent x squared divided by 2 minus 1. All right, to do this, okay, I want you to, okay, focus on the, where is the solution? Draw the graph, okay, draw the graph, and then use all the point that you learned from previous. Okay, n is a b minus a divided by h. Number of grid involved is a b is a 2, a is 0, okay, 2 minus 0, and h is 0.5. Use the okay, information from the equation to create the grid. The grid now is a 4, x0, x1, x2, x3, and x4. However, the value of when x0, okay, y0 is equal to 1. So your graph start from y equal to 1. So you know the initial value. Okay, we want to find the value, others value, y1, y2, y3, and y4. All right, so that is keep in your mind. Okay, so we want to also apply Taylor series to find y1, y2, y3, and y4. Y0 is given as 1. It's an initial condition for the first order initial value problem of ODE. All right, ODE. All right, so now, so what's your intent to do is we want to draw a graph to find what is a y1, y2, y3, and y4. All right, so you also know the grid. Okay, the way of the dimension, okay, the domain of the solution. All right, so now let's restart. All right, so we already know about the okay question here. Okay, the question here is a y prime equal to x minus x, plus xy. We want to find Taylor series. What is Taylor series? Keep in mind, okay, again, please keep in mind again, Taylor series is involving yi, yi prime, yi prime prime, and yi prime prime prime. Up to third order of their derivative. All right, so now let's we apply. All right, so when we apply here, okay, we need to find what is the yi prime, prime, and yi prime prime prime. All right, so based on the question, okay, keep in mind you are given y prime equal to x plus xy. Okay, go to that. Y prime, okay, be careful because you are doing a derivative, okay, part by part. Okay, del x over del x equal to 1. This derivative del x for function xy is a y plus, okay, and then x and y derivative respect to x is equal to x already we differentiate, and now y prime, okay, is the part by part. All right, so be careful here, and then again you apply the derivative part by part again, okay, for y prime prime to get y prime prime prime, okay, third order derivative of y, so you can get 2y prime plus xy prime prime. All right, so I put aside there, all right, how you do the part by part derivative of y prime. Okay, so now, okay, we have y prime, we have y prime prime, we have y prime prime. So now we want to, okay, insert, okay, insert to get when I equal to 0, x not equal to 0, y not equal to 1, which is given in the question. All right, we want to find y1. I equal to 0, I plus 1 is equal to 1. y1. All right, we want to find y1. y1, okay, be careful here because I is a grid. I is a moving from 0, and then I plus 1 is a 1, okay, and then you have y not prime prime, y not prime prime prime. Okay, be careful. All the information you can get from the previous step. All right, so now what should you do? Okay, insert, okay, insert the value. All right, okay, y naught is equal to 1, h is 0.5, y naught prime, okay, put the value at x naught plus y naught x naught. All right, so go to the y prime equal to x plus xy. So all depends on the equation 1, equation 2, and equation 3. All right, okay, so when you insert the value, okay, y naught prime equal to s naught plus s naught y naught is also, you can look at the graph, okay, s naught is equal to 0, y naught equal to 0, so the answer is 0. The second is y naught prime prime is equal to y 1 plus y naught plus x naught, y naught prime. All right, so all information you can get from the previous step. So that's we call as a dependence, okay, step for solving the Taylor order tree. All right, so you can see here y naught prime is a 1 plus 1 plus 0 times 0 equal to 2. All right, so now you continue to get y prime prime prime, third order of the derivative. All right, so put 2 y naught prime plus x y naught prime prime, where the value, okay, is already stated at the previous step. Just insert, okay, and calculate, okay, correctly, precisely. Don't careless, because numerical is what? Numerical is a computational. Okay, you need to compute and compute again. All right, so towards the end, what you get is a all the value of the y, y prime, y prime prime, and y prime prime, and then you insert, okay, to the Taylor series order tree. You will get y1 equal to y naught plus h, y naught prime plus h squared divided by 2 factorial, y naught prime prime plus h squared, h cubed divided by 3 factorial, y naught prime prime prime, third order derivative. All right, so insert all the value from the, okay, single step. What we call this one is a still single step, because you just depend on the one equation. All right, so you can get 1.125. All right, so now what is your mind? Okay, you already, okay, get the, okay, let's we go to the graph. All right, so you can see here, okay, you can see here at the graph, okay, you already get the value y1. Y1 is a 1.125. All right, so y naught is a 1. So you already have a graph between y naught and y1. All right, so now continue. Okay, that is considered as a iterative. Okay, iterative, the same step, you continue to get y2. All right, so y2 is equal to y1 is depend on the grid y1 plus h y1 prime plus h squared divided by 2 factorial y1 prime prime plus h squared divided h cubed divided by 3 factorial y prime prime prime. All right, so you repeat again. You repeat again, all right, means that you need to find, okay, y1 prime, okay, y1 prime prime, y1 prime prime prime, means that you need to find the first order, second order, and third order of the y1. All right, so be careful. Insert the value, okay, x1 plus x1 y1. So all the values already got from the previous step, just insert. X1 is 0.5, y1 already got from the previous step is a 1.125. All right, so you will get the value of the y1 prime. Continue again, okay, continue. All right, so what is numerical? Is an iterative. What is a numerical? You use a same method iteratively. That's why when you want to develop MATLAB or you want to use Keras, whatever, it's very easy. It's very easy because you use the same, okay, iteration, you repeat, okay, you put in the loop, you control the grid, not control the convergent, but control the grid. The grid here is I equal to 1, I equal to 2, I equal to 3, I equal to 4. Just 4 round of the similar formula. All right, so now, okay, again, you can see here, y1 prime prime, okay, you got already the answer. Third order y1, okay, is a already got the answer because it's depend on the previous value. All right, be careful. All right, don't give up. You can get 2.1825. Another one is a 3.21. All right, 3.5658. All right, so now, okay, use all the first order, second order, third order derivative of y1. All right, put all the values. Again, you are similar process. All right, get the y2. Okay, so this is what we call as a Taylor series method. All right, so until when? Until I equal to 3. Okay, until the last point when you finding y4. So what is y2? Okay, come on again. All right, you go to the graph. Y2 is here. All right, so you have another method. Okay, another point. Okay, where the graph is increasing. Started from 1, and then 1.125, and then y2 is increasing. All right, so now we have another 2 point, y3 and y4. How to do that? All right, so the same process. We go to find y3. All right, we want to find y3. So what is your effort now? All right, your effort is a skill of the computational. What is your effort? Okay, what you need to train yourself is a skill to press your calculator. Press your calculator. All right. So this is a skill that we can improve. And then second is using a formula. You remember the formula. You know how to do the iterative manner. All right, to get the y3. You can see here y3, the same step you need to find. All right, y2, first derivative, second derivative, and third derivative. All right, so all right, so now you insert all the values, okay, in the formula, the first formula of Taylor method, okay, degree 3. Okay, so you can see here, okay, I'm generating y4. Okay, why we stop at the y4? Because the interval is between 0 and 2. Okay, there is a boundary between 0 and 2, so you stop at y4. All right, y4 is a okay, go to the graph again. Okay, where is the graph? Okay, y4 when x equal to 2. Okay, when y4, okay, is when x equal to 2, we want to find the temperature behavior at the space x equal to 2. Okay, x naught is when x equal to 0. All right, y3 is when x equal to 1.5. Okay, so set in your mind, all right, where is the point and where is the location, how to draw the graph. We give you marks when you know how to transform from question to the graph. So this is a step you need to remember. Okay, transform question to the graph. Remember the formula of the Taylor series order tree, and then how to apply Taylor series order tree by using the first, second, and third derivative of yi, and then insert to the formula of the Taylor series to generate y1, y2, y3, y4, and y5. All right. So let's we go to the y5 and y4. Sorry. Okay, y4. What is the answer? Y4 is a y3 plus h, y3 prime plus h divided by 2 factorial, y3 prime prime plus h power 3 divided by 3 factorial, y3 prime prime. So what I'm doing now, okay, I'm stop sharing. Okay, what I'm doing now, okay, I'm stop sharing. Okay, again, okay, okay, I'm stop sharing. Okay, I hope that you can answer my question here. Okay, okay, can you describe the step to solve the first order ODE using using Taylor series. Okay, we are using Taylor's order tree. Okay, we are using Taylor's order tree. All right. So now, okay, I send to the okay, I send to the chat here. Okay, if you can help me to answer the question, please. All right. All right. So now, okay, my question here, okay, is can you describe, okay, okay, can you describe, okay, the step to solve the ODE, okay, using Taylor series? Okay, what should we do? Okay, the first is what? Transform, okay, transform question, okay, to graph. Okay, from graph you can get the domain of solution. Okay, domain of solution. So you know the location. Okay, where is the solution? All right, transform. This is first. Okay, and then second, what is that? All right, apply. Okay, generate, or we call as generate lah. Generate. Okay, y prime. All right. And then y prime prime, because let's say you want to use a third order derivative, all right, so means that you need to go for the okay, the derivative for yi for first order, second order, and third order. All right, and then okay, after that, okay, what should you do? Apply. Okay, I'm using third order. Okay, I'm using third order. All right, third order. Okay, Taylor series. Okay, I sometimes I say okay, Taylor method. Okay, Taylor method, because this is a all right, numerical, so we put as a Taylor method. Sometimes you can say that Taylor series. It depend. All right, so and then what is the last? Okay, okay, the last is okay, get the table. Okay, get a table of the solution. Why? Because we want to compare with the exact solution. Okay, and compare. Okay, if there is a exact solution, compare to sometimes we call as analytical. Okay, analytical. Okay, analytical solution. Okay, means that exact solution. This is a given in the question, which is a given in the question. Okay, you can go to the chat. You can see my. Um, my answer here. Okay, okay, you can go to the chat, you can go to the solution here. Okay, who are okay, you can see, go to the chat, you can see my solution. You say my question is describe the step of the Taylor series to solve ODE. The first, you need to do what? All right, transform, okay, the question of the ODE to the graph. Okay, I transform already. Okay, x between 0 to x equal to 4, y not y1, y2, y3, y4. You so the graph is increasing or decreasing. It depends on the how you generate the solution of uh, first order, second order, and third order of y. All right, because the Taylor series is depend on the third order derivative of y. All right, so I is depend on the grid itself. I equal to 0, I equal to 1, I equal to 2, I equal to 4. So I is a grid. Okay, the location of the grid. Y is a solution, the temperature behavior. I is a dimension, all right, of the solution. And then the third okay is a apply. Okay, apply Taylor series. In our case, we are using third order Taylor series. Okay, sometimes I'm using second order. All right, we seldom using fourth order Taylor series because it's equivalent to Ranch Kata order 4. All right. Okay, so now the last is okay, transform all your solution, okay, into a table and compare between the approximation solution from Taylor series and exact solution from the analytical solution that we give you in the question. Right, so this is a logic thinking, mathematical thinking, okay, numerical thinking, okay, to solve the uh, Taylor series, okay, for ODE first order. All right, so now I'm stop sharing. Okay, I'm going to go to the okay, I'm stop sharing. I want to go to the video again. All right, so I think all right, we focus to the video. Okay, let's I focus to the video. All right, so you can see here, all right, after getting y1, y2, y3, y4, all right, so you already know, okay, the value of temperature behavior at the specific point when x equal to 0, when x equal to 0.5, when x equal to 1, when x equal to 1.5, and x equal to 2, all right? So, okay, if I can draw the table, okay, you can draw the table. Okay, find the table, get the solution, all right? Okay, so for example here, I'm not creating the table, so never mind. I stop sharing. Okay, I go to my notes here. All right, I'm stop sharing. Okay, I go to my notes. Okay. Mm, okay. All right. So this is a notes. Okay. Right, if I can open here. All right. Right, so I continue again. Okay, if I can go to another notes. Okay, if I can go to another notes. Right, I'm stop sharing here. I go to another notes. Okay, yes, I share this note. All right, so okay, we want to continue what happened. Okay, what is the okay y4 y5? All right, so this one I want you to okay transform from y1 y2 y3 y4. Y4 is a solution here. All right, so after getting y1 y2 y3 y4, all right, so transform into the table. All right, so insert all the answers in the table. All right, so you can see here, okay, as I is given in the question, okay, you generate, okay, from 0 to 2, all right, you have 4 points here, and then yi you get from the Taylor series order 3, and then exact solution is given in the question, okay, given in the question. All right, so you list all the exact solution and Taylor series grid using okay the same question here, and then get the error. The error, there are so many types of error. In our case, okay, I'm using absolute error. The difference between the approximation solution from Taylor series order 3 and exact solution from the question given in the question. So the exact solution we call as a yi minus y exact solution. Okay, that is an error. You do a summation of the error. Okay, so you can see the error is very big. Okay, very huge. Okay, you can see 0.10162 plus 0.0573 plus 0.2206 plus 0.9975. You can see the last point is contribute higher error. So now my question that you need to think, how to reduce this error? What is the error? Summation error between the exact solution and the approximation solution from the Taylor series order 3. All right, so now how to reduce the error? Okay, the difference between, okay, when you minus, okay, you can get the difference. So to solve this problem, you can go to range kata order 4, or let's we go to the predicted corrector method. Okay, this is a new method in numerical 2. All right, so we are going to solve this problem. Okay, the same problem, the same first ODE using predicted corrector. Okay, the same style. All right, but the method is enhancement from the Taylor. So means that we can correct the Taylor series, we can correct the Euler series, Euler method, we can correct the Rajkata method. Correct in terms of what? Correct in terms of reducing the error between exact solution and approximation solution. All right? Okay. So now, let we stop. Okay, let's we get the feedback from others. All right. So all right, so now let's we get the solution from others. Okay, any question? Okay, all right, so there is a question from Chan Chong Lee, doctor, how to open RNR file? RRR is a zip file. Okay, so okay, very easy. You just click and then do not to buy the software. You just go to the file, because in the zip there is a directory. In the directory there is a file, so click the file. The file is there. It's a chapter 1, chapter 2, chapter 3, chapter until chapter 9. All right, if you have a problem, let's go to the group. Okay, they can help you. Okay, and then this is a question. Okay, so this answer from Putri Azrin, try to change the type of file. We cannot change the type, but we can transfer the type from zip file to PDF file. Okay, change cannot. Okay, right. So you can also go to the online. Online. How to how to transfer zip file to PDF. All right, go to online. Okay, transfer zip file to PDF. All right, so no need to upload. You just use the online system. All right, so this is a style. The way now how we can solve the problem without people helps. Okay, because we are distant. All right, and then you and your friends is distant already. All right, so get help in the group. Okay, this is my question here. Okay, how to so my question here is what? How to reduce the error. What is an error? Absolute error. Okay, what is error? Is an absolute error. So this is a question that we are going to answer in numerical 2. All right. So that we're going to learn a few methods, to enhance, the mm, accuracy. Okay, error 2 is dealing with the accuracy of the Euler method, branch kata method, or Taylor method. All right. Okay. So now, towards the end here, I hope that you can go to your Telegram. You know why? Because I want to confirm. Okay, I want to confirm your attendance today. All right, because sometimes QR code we are early. Okay, we are very early. Scan. All right, so now go to the your Telegram. Okay, and then please submit your answer. Okay, submit your answer. Before 9:15. Okay, 9:15, because when once you submit, there is a time duration. Okay, I can see the duration. Okay, please go to the Telegram. All right, so you can go there. Okay, if I can get a link uh, from the chat. Okay, I can share with you at the chat. Okay, you can click at the chat. Okay, go to the this simple exercise, that I remind you early in the morning. All right, go to the chat and then find the solution. Okay, you can refer to the books. Okay, and submit before 9:15 to confirm your attendance. Okay, why? Because sometime we want you in the class. Because it's very important. All right, so we want to confirm your attendance here. Right, we want to confirm your attendance. Right, so this is very important. So let's we go to the exercise, simple exercise. Okay, don't worry. Okay, give the answer, very simple answer. You learn already chapter 9 and chapter 8. Address your solution. I'm waiting you at the Padlet. All right, I'm waiting you at the Padlet. All right, so now okay, can I get more result here? Okay, I'm waiting. Okay, I'm waiting. I hope you can answer now. Okay, before 9:15. Okay, refer to the books. Okay, until now. Okay, there is no feedback. I'm waiting you. Oh, there is a feedback. Okay, please write your name. Don't put anonymous. I don't know. Okay, please correct your what your names. Okay, don't put anonymous, because I want to detect the attendance. Okay, anonymous, please write your name. Okay, very good. There is a good feedback now. Wow, thank you very much. Okay, Nurul, thank you very much. Ko, thank you very much. Eugene Ko, thank you very much. Okay, Singyi. All right. And then Nora Malia Farisha, thank you very much. Okay, please write your name. Okay, your answer is correct, but I don't know who it is. Okay, Leonard, Leado Lance Lee Lingziu. Thank you very much. Okay, very good. Okay, means that you understand what we talk about today. Azim, thank you very much. Azim Akif, thank you very much. Okay, anonymous. Okay, don't say cancel. Okay, you can go to the you can rewrite again. Okay, never mind. Write your name here. Thank you very much. Okay, all is correct. Okay, but Azim tu tak correct tu Azim. Alright, what is different between ODE and PDE? This is not correct answer. Alright, bukan first order, second order, third order. No, 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 no. What's different? Okay, what's different? Alright. So, thank you very much. Okay, very good. Okay, very fast feedback now. Okay, I cannot catch up you because it's too fast. Thank you very much. Okay, I'm waiting you until 9:15 with the name, and I want to confirm your attendance. All right, based on a simple exercise, and also to make sure that you are doing a self-determined learning. You are doing centered learning. Okay, using my e-content at the e-learning. All right. So since you are answering this question, okay, I want to go to group one. Okay. All right. Okay. Okay. I want to go to the group itself. Okay. How you form your group. So I'm worried because okay, I'm stop sharing. I'm stop sharing. Okay. Still keep going. Okay. To my exercise to confirm your attendance. Okay. At the e-learning. The same time, I'm going to share with you. Okay. The group here. I'm quite confusing because okay, still not full 5 members. Okay. For example, here. Okay, group two, how many? Okay, 5 already. Alhamdulillah. Group three, okay, let's we go. Group three, okay, 5 already. Alhamdulillah. Okay, group Siti Azrin is 5 already. Alhamdulillah. Group five, let's we go to group five. Okay, how many group five? Okay, 1, 2, 3, 4. Yes, Alhamdulillah. Group Chong and Jua. Okay, very good. Thank you very much. Okay, and then how many your group? Okay, uh, Leonardo Lance Lee also here. All right, and then group. Okay, there is. Please put your group name. Yeah, group name. Group name is a Leeds. Wow. All right, and then you have 5 members. Okay, Ayu. Thank you very much. And then let's say Nurin. Nurin, how many? Okay, members now. Okay, 4. Very much. Okay, what is your group name? Your group name is FX. Wow. Wow. All right, and in group Nur Akila. Okay, what is your group name? Please put plus there. You can put plus. Okay, if you have a problem, okay, please put plus. I will correct your group. And then, this one group. Okay, your name also member only 3. Chan Choli, please invite other people in your group. All right. Nor Saidatul Lain. Okay, you have 5 members. Your group is amigos. All right, and then this one is Chan Chong Lee. Okay, how many members now? Oh, sorry. All right. All right, so there is a 5. Okay, 5 there. What is your name? Name group is still not here. Okay, Pai Zozi. Okay, how many members here? Is 5. All right. So who are still not in this? Okay, still not have a group. You can go to a group which is not more than 4 members. Okay, 4 members. So I'm waiting you in the group. All right. So this is a progress how you perform the group. And then I hope you also can increase your or update your introduction to yourself, and then your internet connection. Okay, today we are moving. I'm also moving to other room. All right, why? Because I need a multi environment. So Alhamdulillah. Okay, okay, we have plenty of room. We can go anywhere we want. Okay, the important is we keep keep contacting each other. All right, so now from Nurul, can you delete the empty box for group one? We cannot edit it. Oh, yeah, yes, very good. You cannot edit. I'm going to edit, but I'm waiting others, okay, if they can still not get a group, okay, they can form one group. All right, so never mind, I can do it. Thank you very much. Okay, that's why we talk with the system. All right, okay, go to the e-learning, okay, and then I want to stop sharing. Go to the e-learning and please okay, do your self-determined learning. I'm only a coaching. I just want to make sure you, all right, conquer your subject, all right, understand very much. I'm going to support you any digital notes, all right. Even though I'm still okay learning from the e-learning, all right, but there is pro and cons. I'm trying my best to deliver a good way to make you understand. And if you have a problem, let's go to the Telegram. All right, bye bye.